Hey everybody, let's prove the law of sines. So the law of sines is written right here, and it says that in any triangle, so it's no longer just right triangles that we're working with, any triangle, this relation holds that the sine of A divided by A is equal to the sine of B divided by B is equal to the sine of C over C. So this ratio, this relation holds in any triangle. It doesn't matter at all. Let's prove this. So here's our arbitrary triangle ABC. I know it might look like this is a right angle, but I promise it's not. At least I tried to draw it, so it's not. So in ABC, what I'm going to do is I'm going to drop an altitude from C, meaning a line that runs from the vertex at C and is perpendicular to the opposite side, side C. There, that's an altitude. We also refer to this as what? We call that the height of the triangle. So remember back when you had to calculate area of a triangle? We said area is 1/2 base times height. So the area of this triangle is 1/2 times C times the height. Yeah. Okie dokie. Well, notice that dropping this altitude creates two different right triangles. The right triangle on the left, right here, and then the right triangle on the right. Okie dokie. And we've done a lot of work. Should be the case that at this point you've done a lot of work with right triangles. Well, what can we say? Sine of A. What is sine of A? Sine of A is the opposite side over the hypotenuse. What's opposite A in the right triangle? Height. What is the hypotenuse of this right triangle? It's side B. So sine A is equal to opposite over hypotenuse, h over b. Well, similarly, sine of B, what is the sine of B? The sine of B is opposite h over hypotenuse. This time we're looking at this triangle right here. What's the hypotenuse of that one? It's side A, so h over a. Well, these have the matching h terms. Let's solve these both for h. So from this left-hand equation, I get that h is equal to b times the sine of a. From the right-hand equation, h equals a times the sine of b. But if both of these are equal to h, then they're equal to each other. So b sine a equals a sine b. And from here, what I'll do is divide through by b, divide through by a, and we get sine of a over a equals sine of b over b. Or, alternatively, we could have also divided through by sine of a, divide through by sine of b to arrive at b over sine of b equals a over sine of a. And these are both like, you know, they're both true. They're both, they both follow. And you could do the exact same thing, like if you just reorient this triangle and draw a new height, then you'll find that sine of a over a is also equal to sine of c over c, which gives us the law of sines. Sine of a over a equals sine of b over b equals sine of c over c, or equivalently, a over sine of a equals b over sine of b equals c over the sine of c. They're the exact same thing. Both of these are the law of sines, and one is more useful than the other, kind of in terms of what you're solving for, just because it might give you fewer steps. If you're solving for an angle, you might want to use this top one, since all of the angles are already in the top. You're going to have to use the inverse sine at some point when you're solving for angles, just so you know. If you're solving for a side length, you might want to use this bottom variation of the law of sines. Okay? That's it.